Welcome to Chemistry in the Air. I'm your host, and today, it's a beautiful sunny day outside. God is good. They won't know if it's recording or this. And we're expecting a high of 23 today. It's like June. Okay, anyways, we're going over yesterday's questions. I'll just talk about them a little bit here. CH4. Now the trick is you go through the rules, and there's a rule for hydrogen. Use +1. So I kind of backwards read. Right? There's 4 groups of +1. Carbon had to have been -4. With SO2 of the dioxide. I use the reasoning that if oxygen is -2 and I have 2 groups of it, you can do the arithmetic on the side. It would be -4, so we needed a +4. MnO2, manganese dioxide, manganese oxide. 2 groups of -2 means that had to be +4. Same reasoning as B. D and E were pretty easy. They're ions. Just take their charge. Okay? This one. +5 for the nitrogen because each oxygen is -2. That adds up to -1. H3O, the hydronium ion. We're familiar with? +1, -2. That wasn't too tricky. It's what you expect. Bigger. Now this one said it was a peroxide, and I told you if you have peroxide, I will tell you. That means you use -1. Sodium is positive. Okay. Magnesium hydride. In a metal hydride, so when hydrogen is second in quantity, that's where you use -1 for the hydrogen. Magnesium is 2. That one you might use. Cr2O7. This is where you something probably somebody asked me last time. Anyways. -2 for the oxygens. There's 7 of them, so -14 adds up to -2 because that's the overall charge on the dichromium ion. Figure it out. 6 apiece for the chromium. Okay. This is the one that, here's my reasoning. I told you I wouldn't give this on a test. But if you recognize potassium permanganate, you might know. That's why I said this last one is tricky. It's potassium and permanganate. Potassium is pressure, so that's where I do. This one is just a little bit. So then what I think is I've got MnO4 with permanganate on it. It's on the minus sheet. Anyways, MnO4 with a -1. So it adds up to -1. You've got 4 oxygens, that's -8. Doing the math then, the only way to get that is 7 plus -8. That's what this came. I wouldn't give this to you on the test. I would give you this, though I'd give on the test. Alone. I'll give you 2 things at a time. Okay. Is there any overall questions though regarding? I'm waiting. No? Okay. Then there isn't questions. Let me see here. Oh, this is figuring. So then again here, then don't worry about the top, the bottom. Take a moment to write out this reaction. We're going to figure out what's reduced. So in order to figure out, and I sort of showed you this before you had all the skills, but we've got to figure out what the oxidation number of each item is. So I'm going to kind of do that scratch work in green. Just around above the equation or below wherever you have to. When I look up calcium, and it's in a column, don't explicitly ask for this, but you got to figure it out. Chlorine, chloride ion, is a -1. Oxygen in element form is 0. Calcium is 2+. Oxygen as an ion is 2 negative. Doesn't going to write it down. Okay. Always write it out for one element. Don't, even though there's 2 Cl's on the left. Why is it 0? Yeah, something happens to the reaction. But quick answer is, why did I put 0 there? Because when it's at alone as an element, there's no trouble. Same with the oxygen. Good question. Now, I like blue. So, reduction, reduce. When you have the numbers from left to right, which one goes down? This reduces from left to right. Calcium, no change, right? So it's not out. Chlorine goes from -1 down to 0. You're wrong. Because it goes up. Yeah. Like the temperature. -1, 1's up to 0. So it's oxygen. It goes from 0 down to -2. I just agreed with you. We're wrong. O2, oxygen. Now, in a compound, I put O in. I don't know, but this is just oxygen, so I'm just putting down O2, reduced. Oxidized, it's the chlorine that goes increasing. But I always do reduction first, and then I know the other ones. It is the Cl in the calcium chloride. That one, I want you to be specific which element it is, because there's 2 examples, right? That's why I write it down. Now the vocabulary, reducing agent. If oxygen is reduced, O2 is reduced, what was added to it? It's the compound, this CaCl2. Oxidizing agent. What was added to calcium chloride? It was the oxygen. Now, I want you to notice, for questions like this, reducing agent, oxidizing agent, left side only is eligible. You can only use reactants, never even consider the product. Makes sense? Okay. Now, where's this going? We've got to do some examples here. What about half reaction? So when you have a full reaction, you've got to figure out each individual. I give you let's see. I'll give you a second. By looking at this again, this is not full reaction, this is partial. I don't see directly what is going on. I have to figure out what the end. I'm going to assume in my scratch work that oxygen is negative. On the left, if oxygen is -2, that's 3 times 2 is -6. It adds up to -1. So what does the nitrogen have to be on the left? Let's be positive, but -6 plus something gives me -1. But two groups of oxide ions, so -4 adds up to -1, so +3. Did you get any symbols? Or I know. I don't know this. I don't know the hand signal. The only gang I've ever belonged to, and like, for a few years, to get along, we just went out and shoveled people's walks and things like that. Flowers for people, old ladies pushed across the street. And anyways, it's really nice. Good vibes only. Okay. Now this is a half reaction. It's not going to have something that's oxidized and reduced. We got to have something. So this is a 5 down to 3, so it reduces with the nitrogen. But this half reaction is a reduction. So I'm going to write that down. I'm going to label this reduction. Okay. This is what you're going to do in question 4 on the handout. Now, you don't have a textbook, but I labeled it K616. You know which number 4, because there's other number 4s. You're doing those questions. There's ABC, 5 questions. So you've got to split them up. You're only going to have one answer. Reduction, oxidation. If nothing changes charge, then it's needed. Okay? If that would have been nitrogen 5 on the left, 5 on the right, it would have been needed. Okay? Give you time. Okay, we've had a chance to take a look at these questions. See. Want to look at that one? Did you guys get oxidation for that? Right? I'll just only go over them if you need me to. Reduction. Remember, an element by itself is 0. Nothing happened here. Neither. Not reduction or oxidation. This one's oxidation. So it increases in charge. Was that one more? Yeah. And then we have reduction. Any questions about any of those 5? I'll repeat, because I'm now recording. Do not write all these colored steps. Look at the back of your handout, where you have your oxidation number rules, and the second half is balancing reduction oxidation equation. Everybody's with me on this handout, right? Okay. You don't need to write anything down yet. But I'm going to talk to you quickly. Okay. You notice how the first 5 rules say acidic solution, right? Well, when I say acidic solution, it means you can use water and what do acids donate? H+. You can use that to balance atoms if necessary. We'll see how this works. Now, I'm not going to go over the steps, but I skipped because right now we're only doing a partial, a half reaction. So we're going to skip step 1 at this minute. There's one thing we do have to consider from step 1. It says here, separated to 2 half reactions. We'll assume it's separated. But balance what you can without worrying about oxygen or hydrogen is step 1 action. Sometimes we have to look at that for this. But we're going to really more or less start at step 2, 3, and then 4. Okay? So what you're going to write down, now it's something to write down. Example, in acidic solution. So write that down. Balancing a half reaction in an acidic solution. Okay? So maybe you want the title, balancing half reaction. Write that down and then in acidic solution. We're using the rules on the handout. I'll pause the video. You can jot that down in video land. Okay. Anyways, okay, back to this. Balancing these half reactions, we're going to assume this is in acidic solution. Here's how we do it. I'm going to use my colors. Step 2 or 3. Now, the first step I said we're not really using, but we do have to balance for things that aren't oxygen or hydrogen. Right off the bat, NO goes to N2O. Okay? So we've got to balance for nitrogen. So what do we need to do, left or right? Don't worry if it screws up the oxygen. It's not the issue. So, first step. What do we do? Balance for nitrogen. 2. Yeah. We're all with. Then we move to step 2. If needed, balance for oxygen using water. Well, we can do this because it's assumed an acidic solution means that it's an aqueous water-based solution. So there's plenty of water. Right now, I'm looking at this means we've got 2 O's, we got 1 O. We need more water on the right hand, or we need more oxygen on the right hand. So we'll add 1 water because that adds 1 O. I know it screws up oxygen, but that's okay. That's a step 3. Okay. It's acidic solution, so step 3, if needed, we do need. Now it's for hydrogen, H+. So I need 2 protons. I'm leaving spaces here because I probably need to adjust the balance. Oh no, I don't have these because that's actually balanced. When you have both, you're adding 2 reactions. Getting ahead of myself. 4. Balance for charge using electrons. So this is where I say on the left side, I got +1 and 0. Right? So I've got a grand total of +1 on the left side. On the right side, I have nothing and nothing. Right. Always bring the high side, the +1 side, down to the low side. Because we're adding electrons. Those are negatives, so we won't bring them down. So +1 has to come down to 0. So we added 1 electron. There I go. That's good. Can I see what I did there? Yeah. Ask me. Right. Thank you. I screwed up, and that'll screw up everything else. I'm busy talking. 2H. Now that changes it to +2, which means we need 2 electrons. Thank you, Isaiah. Okay. Totally messed up. What we call it. Any questions there? Well, here's what I want you to try right now. Is on that handout, 1, 3, and 4 on the page 623 part of that. So those are all acidic. 1, 3, 4. Okay. Give you time to do them. If you're on the video, these are the questions that we're doing right now. And I have an example. All right, here are the solutions to 1, 3, and 4. Got it. So I'm going to go over. I'll go in order. So I look for things first. Black is what we have, right? Cl to Cl, good. I need 2 waters for 2 oxygen. Now I need 4 hydrogens. Oh, not, but I have 1 already there, so I need 3 additional. Now, how do you get 4 electrons? Before I put this on here, basically, how did I do this? I've got 3 positives on the left, the right. No, that's wrong, the left. I got 1 negative here. You bring the high side, 3 down to -1. The only way to go from 3 to -1 is to subtract 4. 4 negative electrons. Big temperatures. Yeah. So before we have this, 4 positives, 0 on that side, right? So 3, 4. You got it? 6 on the left side, 4 on the other side, so it comes down. Okay. You try to get the charges equal. So there's 4 positives here and 2 positives here. So 6 on the left. Okay. That's good. You're doing it. Yeah. Equal charges. Left and the right are equal. It happens to be 0 a lot of times, but don't get that stuck in your head.